In this video, I'm going to present a lecture format discussion of attribute-based querying or selection by attributes. This is the first of a variety of analysis techniques that we'll learn through the rest of the semester that can be done in GIS. Next week's topic will be location-based querying or selection by location. In order to talk about selection by attributes, we need to do some review of what is an attribute. An attribute is the data side of a geographic database as opposed to the spatial side. The spatial side creates boundaries and locates a feature in space. The attributes provide identification and data that can be attached to and associated with each of those features. Attributes are stored in a place called the attribute table. If you've viewed a shapefile, such as we've been using in Windows, what you'll find is that each shapefile is made up of a group of subfiles, each one of them having its own particular use. Each of these four boxes represents a single spatial data set. In the case of the attribute table, it is always called the DBF file. DBF, in each case, holds the attribute table for each of these four separate shapefiles. In order to get at the attribute table, one needs to right-click on the name of the theme inside the table of contents. That'll open up a drop-down menu of which one of the choices is Open Attribute Table. This provides access to the attribute table. What the attribute table looks like is very much like a spreadsheet. It has rows and columns. Each of the rows is the collection of data that's associated with a single feature, in this case a single polygon, and each of the columns is one particular type of data. What's being illustrated in this figure is that one row of data with a name, Hamilton County, with a FIPS number, whatever that is, a particular area, and a particular parameter is one record, one set of data in the attribute table. One line is associated with a single feature in the spatial data set. Together, they make the spatial data and the attribute data make one complete data set. These selected features are designated by being colored this peculiar color of blue called cyan. There is a strict one-to-one relationship between one polygon or one feature in a spatial data set and its associated single line representing all of its attribute data. As an example of another example of an attribute table, this is an example of the attribute table that would be associated with a common streets database format. Each row in this attribute table, which certainly would go much further than this screen shows, each of these rows represents a single line segment, each row, and in each row what's visible here is the prefix, the street name, the street type, any suffix, and the address ranges that are associated with that particular street segment. So this is a common format for a streets database. A little more about what an attribute table is. And each of those, as I said, are visible and highlighted there. Had I not known what each of those columns represented, what type of data it stored for each of the road segments, I would look in something called the metadata, which is a file usually associated with the shapefile. Metadata is data about data, and within this this text file that gets, or HTML file that gets carried along with the shapefile, one will find the definitions of each of the column headers. So what can one do with an attribute table? Much like a spreadsheet, an attribute table can be sorted. Summaries of each type of data can be prepared. Records and their associated geometries can be added or deleted. And calculations can be done upon the fields. We can find the average length of something, the average size of something across all of the features in the data set, and we can do things called joins, which will come up later in the semester. One warning about attribute tables: any data set that you download is likely to, and not just possibly, but likely to have some incompleteness, some inaccuracy, or data that may not be exactly as you suspected, or parameters that might not be defined in a way that you agree with. So one has to take any data set that you download with a grain of salt, and generally data sets from reliable data sources and ones that are used frequently are of very good quality. But they all, even census data has known errors in it, and some data sets have substantial errors. So think carefully about how important the data is and what its significance is. Now we talk specifically about the process of selection. Selection is something you're probably familiar with, perhaps in other applications such as Microsoft Word. If you want to make boldface or italics on a piece of text, you'll drag your mouse across, click and drag your mouse across that text to select it, and then everything that's selected can be then bold or italicized or something. Selection is a very similar concept in ArcMap. It allows us to choose a subset of features in a particular data set. Why would we do such a thing? Well, it allows us to create summaries of subsets of our data set. Maybe we don't want to look at all the roads. Maybe we only want to look at the roads in the northwest quadrant. If we can select the roads in the northwest quadrant, then we can do a summary of just those roads. If we want to identify and do something with all features that meet some specific criteria, that's a slam dunk for select by attribute. We can select by attribute to subset a data set and create a new data set from it. Selection is often part of multi-step complex analyses. In general, we select in order to isolate, for some reason, features that meet a certain criterion. One thing that ArcMap does for us, which is very convenient, is that anytime we perform a table operation or a number of other operations, and we have a subset of features selected, the operation will be performed only upon the selected features. So if only half of our features are selected, any operations will only be performed on the selected features. If nothing is selected, most operations will perform on all of the features. There's various ways to create a selection set. One that's possible is to select by a graphic, and it's possible to draw a box or use another feature to select all of the geometries within a particular region. This is under the Select Features tool, and it's possible to use a rectangle or an irregular polygon. This is not a commonly used operation. Operations that are much more commonly used are an operation that's much more commonly used is one called manual select. And in your toolbar, you'll notice a tool that has a partially selected group of features and an arrow. And what this does is it allows you to select features manually by using click and drag with with your mouse. And if you just click and drag, if this feature was active, if you click and drag across across your screen, you will select a subset of features. The most commonly used method to create a selection set is to use select by attribute. And this can be done either using a dialog box or manually. Each of these operations that I'm discussing at this moment, I will show you in a demonstration video separate from this one. But it is possible to go into an attribute table and just select rows just as you would select a bunch of, or similarly to how you would select a bunch of rows inside of a Excel spreadsheet. And that's called tabular select by attribute. It is also possible to enter a dialog box and use select by attribute in conjunction with an SQL, structured query language query, which will be very obvious once you see a live demonstration of the use of this. This allows you to say something like, select all of the features in this that have a size greater than 100. Size greater than 100 is a simple form of an SQL query. These are just a summary of what happens when one selects by an attribute. To find the dialog box for select by attribute, it's under the selection menu, and under that there's a subset called select by attributes. Basically one of these, there will be a live demonstration of this as well. What this shows is a completed dialog box which tells a story or makes a complex request to the computer to essentially select all of the buildings and only look at the ones that are already selected. That's another level of complexity, for which the year which they were built in this case is newer than 1990. So we'll identify from all the selected features, not from every one of them, so we have a fairly complex query here. I'll show you another example in the live video. And this will we'll find all the buildings built since 1990. And that demonstration will be following in the next video.